Okay, in part 1 we have seen up to this stage. Now let's proceed. Let us understand from the graphs. Okay, so let us talk of graphs for motion. Let us talk first about distance time graph. Distance time graph. Look at this graph first. This is the distance and this is in meter and this is the time in seconds. What does this line represent actually? This line which I am drawing here, what does it represent? This line. Okay. If you look here from 0, let's say this is at 5 meter. The object is always at 5 meter. So, is it moving or not? That's a question. Okay. I'm sure you know the answer. Obviously, the answer is, we all know, no. Okay. So, if it is not moving, then what does this graph represent? Then the graph shows an object is stationary. Okay. Let's talk of second graph now. Let's select another one here. B. Not B, sorry. Let us talk of second type of graph rather. Let's talk of this one now. This time, the distance which is in meter, time is in second, has a line which is going like this. What does this line actually represent, you think? Okay. You know, if I draw this way and if I label the parts here, something like this, 2, then 4, then 6, then 5, 10, 15. See, if you want to find out the speed between these points, let's say A, B and C. So speed between AB, if you do, speed is distance by time. That will be your total distance from A to B is 4 to 2. So it is 4 minus 2 and time is 5 to 10. So 10 minus 5, which means it is 2 by 5. So it is 0.4. Now let us say we find the speed between anything like AC, let us say AC. So how do we get this? Again, speed is distance by time. From A to C, the distance is how much? 2 to 6. So we have to write 6 minus 2 by the time is 5 to 15. So 15 minus 5, which means it is 4 by 10, which is 0.4. So this is also meter per second. This is also meter per second. If you observe very carefully, you will see that this answer and this answer are same. Okay, is equal to here. Same. So if they are same, or if they are, in other words, constant, then we say this motion is uniform. So such type of motion, the speed is constant. In other words, it is called uniform speed. Okay, where the speed is same throughout. This is called uniform speed. Uniform speed. Okay. Now let us go for the third condition slowly. Okay. So if you go to the third condition, how shall I now plot the graph? Okay. This time my distance, which is in again meter, time in second, but the graph goes like this. Again, let's say I will plot this way. Okay. Look at the time here very carefully. Look at the time here, T1. Look at the time here, T2. See, the time the time is decreasing. For the same distance, see, it is here also d, here also d, which is, say, something like we took up to 4, 6. So the time is decreasing for same distance. Same distance. What does it mean now? If the time is decreasing for the same distance, and we know speed is distance by time, so if time is decreasing, then speed will increase, which means in the less time the object is covering the same distance. So if the less time is covering same distance, it has to go faster. So the speed is increasing. Okay. So this type of motion where speed is changing is known as non-uniform motion. Okay, I'll just erase that. So non-uniform motion. Yeah, okay. Now let us analyze one question. Okay, so let us analyze this question which is given here at the base. Let's say the question shows you something like this. It shows you this way, then it shows you this way, then it shows you this way, and then like this. Okay, and let's say you are having this here, here, and then you can just label them something like A, B, C, D, E. Okay, and this is distance in meter, time in second. How do we analyze now this one? See, from A to B, what can we say? We can say it's a straight line, right? So, one second, I'll just modify this little bit so that you can analyze this in a different way. I'll just do very fast. Okay, I will take like this, then I will take like this, and then I will bring him down. Okay, and so that we don't have this problem. Yeah, A to B is uniform motion. B to C, it is stationary or rest. C to D is a curve, which means it is non-uniform motion. And then D to E, the object is returning back, but it is uniform motion. Why uniform motion? Because even this is a straight line, right? Okay, all these graphs are also applicable for displacement time. Only thing is, in this case we measure velocity. I'll come to that in the third part, where I will solve some questions for you and ask you some questions based on various type of graphs. Okay, all right, thank you.